In this recording, we'll continue our introduction to functions with some additional concepts. So the first concept is that of a mapping. And basically what a mapping is just another way to represent a relation, right? You before had a set of points listed out. You could have a graph of them. You could have words that describe them. If relevant, you could have an equation that describes them. And so what we're going to say for a mapping is it's just a representation of a relation. Remember, a relation is just a set of ordered pairs with arrows to indicate how each domain, that's our x's, element relates to each range element. I want you to copy this definition just like it is. Be careful with your language here, okay? We talk about domain elements. This is a domain element here, 1, -2. Those are elements, just like students in a class. I can't say the class has a particular age. It's elements of my class, the specific students in my class that have particular ages, right? So I can't say each domain relates to each range. That doesn't make sense. It's like saying each class, the whole class, relates to an age. It doesn't, okay? So let's just be precise there, even though it takes a little getting used to. Okay? And so the language we're going to use here is say like 1 maps to 4 and -2 maps to 0, etc. So we can draw a diagram. If you haven't seen this before, it's pretty straightforward. It's done by writing some ovals or general shape like that to represent the set of x values and the set of y values. And notice I didn't do any repeats. Okay, so draw this out and then make a mapping of arrows from each domain element to each range element. So pause and play when you're ready. Okay, so hopefully you did something like this. 1 maps to 4 with an arrow in that direction. -2 maps to 0 with an arrow in that direction. Half maps to half with an arrow to the right. And then -2 also maps to 4, which, as you might notice from previous math study, that's a little bit of an issue there. That's like saying, all right, I was good for those first 3 points. Student number 1 has a particular age of 4. Student number -2 has a particular age of 0. Student number half has a particular age of half. I know that doesn't make a whole lot of sense with negatives, but that's the idea. But then we get the idea here that a particular student, -2, also has another age of 4, and that can't be, right? A particular x value cannot have 2 different y values, so that's not a function, all right? So that leads us to the definition of what a function is, all right? We have to have each domain element mapped to exactly 1 element of the range. And we saw previously that that was not the case. So please write down that function definition. All right. Having done that, let's draw a mapping diagram for this particular relation, which we call S. So I'll give you a moment to sketch out your ovals for the x's and the y's. Don't repeat any if there are repeats. And then draw in all your arrows. Pause, then play the recording when you're ready. All right, so right now I've got the arrows sketched out, the ovals sketched out, and I'll just proceed to draw in the arrows. This particular relation isn't going to be too tricky. Each of these domain elements just maps right across. I guess I could have changed the order. The order doesn't matter in which I list the domain elements. And is this a function? And I guess we would have to think about that. Why don't you think in your head before you play it? Is this a function? Hopefully you said, yeah, it is a function. It agrees with our definition. Every element, every student here has exactly 1 age, if you want to think of it that way. There's no student that has 2 ages. Okay, so we can say, yeah, each element of the domain maps to exactly 1 element of the range, the y values. Okay. Is it discrete or continuous? Think about that for a second and play the recording. All right, so hopefully you thought about that and realized this is a discrete relation. It is not an infinite number of points. it's just 5, right? You can count them, so it's discrete. If we were to plot this relation, we would see points. What's the domain and range? Why don't you write down the domain and range and then play the recording when you're ready. All right, so the domain, remember we write the domain, we're going to make our little set notation. We're just going to list out those very values that we put in our mapping on the oval on the left-hand side. So we're just going to list them out. No particular order, although it might be conventional to put them in chronological order. And then the range would be all your y values. All right, and I'm just going to list them in the order that they were. But I could order them in chronological order if I chose. All right. Now let's look at another relation that's listed as an equation. Okay, so you've got an equation here, the relation x squared plus y squared equals 9. I don't know if you recognize that form, but from geometry, that is a circle. All right, so let's graph that circle. Let's graph all the points that have a center at 0, 0, and a radius of 3. Okay, so I could plot this point right here. I could go up here. I go all 3 points away from the origin. All right, and then I'm going to connect my points. You should do the same if you have a pencil. All right, so there's a decent sketch of our relation. All right, so check, we've made the sketch. Is the relation a function or not? Well, does it do what a function does? Is there a single x value, a single y value for every x value? Well, I don't think so. There's a real simple example. When x is 0, y has 2 different values. Okay, so as I look in this relation, when x is 0, y could have been positive 3, because when I square it I get 9, or y could have been negative 3. And so that's going to be a no. So we're going to just say here no. And one way to say it is the domain element, remember I don't say the domain, but the domain element of 0 maps to 3 and negative 3. Okay, so that's an issue. Is it continuous or discrete? I think you can conclude that it is continuous, right? It is not just unconnected points. It is connected points for which there are an infinite number of them. All right. Finally, if you would write out your domain and range and then play the recording when you think you've got it. All right, well, this is a little tricky for the domain and range. Well, we're working from left to right for our x values. The first x value I hit is at negative 3, and then it's continuous in the x direction all the way up to 3. All right, and it is inclusive. For the range, I'm talking about the y values. Go ahead and put that on our axis here. Our y values are, well, we don't have anything until negative 3, and then it's continuous all the way up to 3. So I have all the y values between negative 3 and 3. Finally, the definition of a one-to-one function. Well, a one-to-one function is a particular kind of function that just has each element of the range with one particular pre-image or x value. All right. So that would be like a situation where you have a particular thing that is unique about yourself, such as your social security number, okay, as opposed to your age, which may not be unique in a classroom. There may be other people in the classroom that have the same age. A one-to-one function is a unique particular element. If I say, hey, who had this social security number, only one person, hopefully, would respond. Whereas if I said, who has the age of 7 or 17 in our classroom, you might have multiple people that do. So I'd like you to take some time right now to identify whether you think these functions are one-to-one or not, or if they're even functions, and then play the recording when you're ready to check your answers. All right, so for this first one, the way I'm going to determine whether it's a one-to-one function, the first thing I need to know is it a function? So I'm going to look at all the x values, 1, 2, and 3. If there are no repeats, then I'm pretty safe that it is a function. Next, I'm going to look at the y values to see if it's one-to-one. So I see repeats here of 4. It's like student 2 and student 3 have the same age. So it's still a function because a student doesn't have 2 ages, but it's not unique. Okay, so I would say this is a function, but not one-to-one. Okay, so we'll just say not one-to-one. You can abbreviate it that way. The next one, I'm looking at the x, y, y. Wait a second, right here, it's not even a function because I've got repeats of a y value. It's like student y has 2 different ages, so that's not a function. Okay. So I wouldn't even ask if it's one-to-one because if it's not a function, it cannot be a one-to-one function. This next one, well, I'm going to think about the graph of this function. It's going to look something like this. It's going to be a parabola. If you were to graph this in your graphing calculator, you would see it. So first off, does it pass what I would consider the vertical line test? Is each element of the domain giving us exactly one element of the range? Yes, it is a function, but it does not pass the horizontal line test, so it's not a one-to-one function. There's a particular y value, okay, that comes from 2 different x values. So this y value of, say, 10 does not have exactly one preimage, so we'll say it's not one-to-one. Finally, this graph down here, I'll just kind of draw it over here. If you were to sketch this one out, it looks kind of like this. Okay, and so this is one-to-one because it passes both the vertical and horizontal line tests. I can't draw any vertical line that would pass through the graph more than once, and I can't draw any horizontal line that would pass through the graph more than once. So let's formalize that by defining what those vertical and horizontal line tests are. All right, now finally, I want to give you a little practice time. I want you to work out whether you think each one of these is a function or if it is a one-to-one function, if it is in fact a function. So pause, work these out, play the recording when you're ready. Okay, so this first example is a function, and it is a one-to-one function because it passes both the vertical and horizontal line test. This second example is a function, but it fails the horizontal line test, so we'll just say it's not one-to-one. Well, first I have to apply the vertical line test, and it does not pass the vertical line test. The x value of 2 maps to 2 different y values, so we'll just say it's not a function. And finally, this example here is a function. Every element of the domain maps to exactly one element of the range, but we've got an issue here. 5 and 12 share the same age, if you want to think about it that way. They share the same y value, so it's not one-to-one. Thanks for watching.